RComp. So when I haven't been doing that, I've been doing RComp. Now, essentially there's three things to tell you about that's particularly new at RComp. There are probably other things, but these are the things I'm focusing on at the show because I can really only focus on three things. We have NVMe, which is high-speed SSD access for a range of our machines. We have new old game, Hexen remastered for latest generation machines, and we have a new version of Autodesk with WebP support. So now you've heard that, you can go. We'll start with, I think, is there anything else I want to show on the Pinebook before we go? I'll do a quick Hexen on the Pinebook, diversions, because one of the platforms that is supported by the new version of Hexen is the Pinebook, so despite the limited resolution ranges on the Pinebook Pro, we can play Hexen very nicely on Pinebook Pro. So if I tick this, we should get some music.
I haven't got the music worked up.
Okay, so you might not be able to hear the music this time, but we'll see how things go. Okay, we may have to do this on something else. Yeah, we're going to have to do something. So I'm going to shut that down. We'll do Hexen on the other one. No matter. I think it was probably trying to change it to a mode that the projector didn't like because of how it's configured it in the front end. But let's do that. And connect up here. So basically what I'm connecting up to is what we're calling a mini.py, basically a successor to our mini.m or minim machine. You will see it available from other suppliers. It's an inevitability of devices with NVMe being quite a limited selection of things available. So if a device supports RISC and has NVMe slot available, the chances are that companies are going to fall over themselves to use it. Now, we held off doing the mini.py until we had the NVMe storage because we're on, but I'm not seeing a picture, so what's going on? We're not seeing any picture. Might be the wrong output.
That's mine, that's
Not sure, I think I was in the wrong HDMI port. We held off doing the mini.py until we had the NVMe storage, because in the original minim we had an eSATA port for external SATA high-speed storage. Previously, without the NVMe support, you'd have had no high-speed storage on this device, which would have made it a poor successor to the minim. Now that we have NVMe working, it seemed very logical to bring out a successor to the minim, and we have the mini.py. Now the mini.py has twin drives. You've got an SD-based drive, which could be eMMC if you prefer, but SD allows for a larger capacity slot. And in the base there is room for up to 256 gig NVMe storage. So that makes it an ideal system to demonstrate to you on here. We're working at relatively low resolution, but that should make it easier to see things on the screen. Now, so since we're doing this, let's talk NVMe. On the mini.py, you can see it on the stand, and we can take orders, and we're shipping that as a product. Now, it starts at £199, and comes with all of our usual software and Forte Tools software for managing the system, as well as our NVMe driver, and the whole kit and caboodle. you know, in terms of value for money, it absolutely rocks. But I'll talk other solutions for NVMe in a minute. NVMe. So, you had hard disks, either by IDE and then by SATA. Then you had SSDs by SATA. And then somebody said, well, hold on a minute, flash memory chips can go way faster than the SATA bus speed is doing at 600 or 300 or 600 megabytes a second. So what we need is a proper flash memory technology that unlocks flash storage. And so the way to do that is to attach it directly to a PCI Express bus, because that's the fastest external I/O bus on a modern PC. And that's how graphics cards connect, basically how all modern components connect to each other at the fastest level. So if we can put the storage chips directly on the PCI Express bus, then it's mapped directly into memory, and it doesn't have to go down cables and through protocols that are designed around hard disk type technology. You just go say, this block of memory goes in this block of memory, job done. So NVMe is the next generation of storage technology above SATA for SSDs. And if you buy any sort of modern PC, if you buy a PC laptop with an SSD in it, it's going to be an NVMe SSD. If you buy a high-speed, or pretty much, you know, if you were to come and buy a RISC keyboard, it's going to have an NVMe main SSD in that. Basically, any modern PC-type architecture machine will be running with an NVMe SSD, unless it's a few years old. NVMe lower power, although they can use a lot of power and generate a lot of heat at the most extreme performance levels. But essentially, it unshackles storage, so speeds in the PC world went up from sort of 300 to 600 megabytes a second for SATA, to, well, the absolute fastest NVMe drives are now breaking 10,000 megabytes a second. So it really is an order of magnitude performance increase. Now, you're not going to see that on RISC, because to do that you need the very latest PCI Express technology and lots of bandwidth through to those ports. The ARM chips don't tend to have PCI Express 5 with gazillions of lanes. You typically get PCI Express 1 or 2, maybe 3, but no, generally PCI Express 1 or 2 with 1 or 2 lanes, which limits bandwidth to more realistic results. I think Chris Hall was probably talking about that in his talk, so I won't go over that again. But basically, although it limits bandwidth, obviously NVMe is still extremely fast storage that we want on RISC. Now, as you may have picked up on if you follow the forums, there are 2 competing NVMe solutions. We started this a year ago. We announced we were doing it for Pinebook Pro. Apparently, other people decided they wanted to do it and get in the active, so yeah, beats me. We've, from the beginning, intended to do an open source solution to our architecture, because we decided, I probably ought to put the RISC dev hat on again, but because it's RISC development type thinking, we thought, do we just fudge NVMe into RISC like most other filing system gets fudged into RISC, or do we tackle RISC filing systems properly? And so, RISC development thinking, yes, we tackle it properly. So, what you get with our NVMe solution that I don't think you get anywhere else is a connected set of components designed to address the future of RISC storage. Now, at the moment, you've got something called file call, which is essentially the guts of RISC storage, and it's horrible. File call was designed for floppy disks. It was fudged by Acorn to do hard disks, back when hard disks didn't even use IDE and were
ST506.
Yeah. We're still using it today. We shouldn't be, but we are, and we have to live with that. And the Acorn disk formats are all based around file call, and it's horrible. And it starts in the middle, because at the time floppy disks were fastest in the middle, because they span fastest. And I mean, it's bonkers. Now, our solution does use file call for the formats, because otherwise you wouldn't be able to read commonly formatted RISC disks with it, and that would be silly. But architecturally, it's based on a concept of blocks, which is how every other modern operating system works, Linux, Windows, Mac, etc. They all work as block-based filing systems. And in the real world, blocks are used for everything. So you want to do RAID on Linux, it's implemented at block level in the operating system, and then the hardware is talked to at a block level. So you have sort of hardware driver, block, RAID on top of your devices, filing system on top of that. So what we've created is an open source, available to everybody, block-based architecture that is plug-in based. So instead of having to recreate everything every time, you just write a little plug-in for your piece of hardware, bolt it into this, and all the benefits of the block-based architecture come free of charge because other people have already done that for you. So where previously a programmer would have to write everything from scratch, so the reason why we don't have partitioning on RISC, for example, worth a mention, is because every single time you have to implement partitioning, you'd have to do it for your filing system that you write. So if somebody writes it for IDEFS, it works on their IDEFS and nothing else, unless another programmer comes along and implements it for a particular version of SCSI, and then it doesn't work on anything else. With the block-based approach, if someone does a partitioning system for the block-based thing, anything that's block-based will get partitioning. Anything that's block-based gets RAID. Anything that's block-based gets device encryption technology for SSDs. So block-based design is fundamental to what we're trying to do. Open source, written in C, 64-bit aware from the get-go. Did I say 64-bit? Yes, I did. That means that our disk sizes don't need to be limited to 256 gig anymore. File core is still limited to 256 gig. That's why you don't want to touch it. But you've got a system fundamentally that understands big disks. That means you want to do a partition, you want to put a FAT32 partition away and sort of the multi-terabyte position on a hard disk. You can, because it's block-based and because somebody else has done the hard work for you. And because it's open source, anybody can use it, anybody can extend it, anybody can have drivers, anybody can have functionality. So you want to add in a block-based, many things already in RISC are sort of block-based, but have been funned in. So CDFS, for example, is sort of block-based, but because nobody actually thought to do it sensibly, it's a mess, and CD handling on RISC has always been a mess. You plug in a block-based driver into block device driver, you've got a much more sensible CDFS. I would have thought RAM disk would be an obvious thing to do this way as well, but we haven't done the plugin for that yet. So essentially you've got all this architecture to cover. Now, I'm not saying that we've got iSCSI and we've got RAID and we've got this today, because we haven't. But the point is that you write a plugin for the block system that implements that, and you've got it on an operating system filing system that supports the block interface. And since other people on other platforms are doing that in a block-based way, then if you were to port iSCSI from Linux to RISC, for example, which now we've got a modern networking stack, it's not beyond the realms of somebody doing it. You've got familiar architectures. It's block-based on Linux, it's block-based on RISC. Makes sense to a programmer, makes it easier. Hopefully it makes programmers happy. And because it's open source, it's not just RComp. It doesn't have to be just RComp. It can be anybody who wants to use this technology can use it. So basically, we've created this architecture and our NVMe driver plugs into that. And this has always been the intent. This is a silly thing. It's open, somebody said to me, Andrew, are you open sourcing yours because your competitor has announced an open source NVMe driver? No, I'm open sourcing it because that was supposed to be my surprise announcement at the show, because it's always been designed because the block-based system is assigned open source. So it would be stupid to have closed source for something that you're wanting other people to use, because they won't use it if they can't see the source code. So fundamentally designed around this to make RISC OS better. The NVMe plugin goes into that. Then there's a bit that connects to file core into it so that you can read file core disk columns. And at the top of the stack you've got the filer, which is almost throwaway. I wrote the filer simply because I wanted an icon on the icon bar. The filer is just basically a bit that sticks an icon on the icon. That just literally does that. So that could be written in BASIC for anybody cares. I mean, I did it in C, but you know. So yeah, also written in C to make porting easier, and just trying to design the whole system to be fundamentally sensibly thought out. We've involved various people in this. I'm just trying to think whether to name drop or not. I'm probably better not because I haven't asked him. But suffice to say that some of the brains behind all of this are names that you would know, and you would be glad to hear were involved in it. Yeah, sorry, I want to, but then I suddenly thought if I don't ask him, it's not fair. So, yeah. So basically, trying to build an architecture, high-speed storage. I'm booting from the NVMe drive now, as you can see. So I'm running my entire system off it. Although I'm calling it beta, it's so beta that I'm running my entire system off it. I won't say it's completely bulletproof because it's not, but it's, you know, you can see. If I go into diversions and run Hexen, for example, now there should be a loading screen. You're certainly not going to see it, but even on the monitor, I didn't see the loading screen because NVMe is so fast. So it's supposed to go like bar percentage completed bar goes across. You just don't see it. You click on it and you go straight to the loading screen, to the title screen. Now, the little machine is so fast. I've got a keyboard. I will type. This is a fun little feature of the port of Hexen. You'll notice that traditionally when the Doom type games, when you get close to the enemies, they go all pixely. When 3D accelerator cards came out, the cool feature that they did was bilinear filtering so that everything went smooth and sexy. It was a sort of 3D FX look back in the day. We don't need 3D hardware to do that. We can walk up to a wall and it goes nice and smooth. Entirely in software. So, the new port of Hexen takes advantage of the speed of the hardware to do all manner of nice graphical effects. I will quit out of that. If you want to come and check out the port of Hexen, come to the stand, I think I would say. What you probably heard just slightly there was some music. Traditionally Hexen used music via MIDI, so these days you wouldn't hear anything unless you've got elaborate MIDI setup. We've basically we found on the internet somebody had done some recordings using some professional grade kit of all the MIDI music and given a very nice license that said basically if you want to use it, give it to anybody you want to. So we thought, that works. And we've incorporated that into the RISC version. So basically all of the, where it would try and play a MIDI track, it now plays a digital audio track of the sound. So you basically get the full experience on machine without MIDI, just like we did the similar thing for the Doom port a few years back. So basically this new version of Hexen is available now on Play Store, it costs £17.50. And again, interesting name drop fact, it's been developed by original programmer Jerv, who did it originally for the RISC PCs back in the 90s. As many of you know, there was a falling out of the RISC people in the 2000s, and Jerv kind of disappeared. He's now back, and he's ported this to RISC 5, and is bringing back his old projects onto modern RISC machines. So it's nice to welcome back an old programmer back into the fold, and to see exciting things coming out of that collaboration again. So yeah, you know, really positive things. Thing I didn't mention about the NVMe, sorry to jump backwards and forwards, but the thing's popping into my head. Question that people have asked me is, does what I'm showing mean that it won't be compatible with what other people are developing? Rule encouraged us to use the same module names and SWIs and things as our competitor, so because it didn't make sense to have two NVMe drivers running at the same time, therefore they might as well use the same SWI. We'll ensure that what we do is compatible with what anybody else is doing. You could even cherry pick certain bits and run them side by side. So for example, if you decided not to use our NVMe plugin, but you did want to use our block device technology with other filing systems, that's fine, it would still work with the NVMe stuff that other people are doing, or you could use all of our architecture, and something like Partition Manager would still work because of the SWIs. Obviously we would encourage the Partition Manager guy to program for block device driver as well, because once he does it for block device, he doesn't have to do it for anything else, because as long as things use block devices, the commands he's calling from his code will work with anything that's block device driver. That makes his life extremely easy, because he only has to write the code once. But that's up to him, I'm not going to force it down his throat. So basically, different but compatible, open source. Annoying that we've got two versions. I wish people would talk to me. I did say we were doing this. I don't understand why people don't, but that's life. But hopefully you understand the benefits of the block architecture that we've built and why we might want to do that going forwards for a more exciting future for RISC or storage. Now, machines with NVMe in. Obviously I showed you the little mini Pi. We also have a range of chassis with NVMe-based motherboards in that allow us to do more sort of traditional desktop computers, because we know that a lot of people are still holding them back, not back, that's the wrong word. They're still using ARM-X6s and sort of titaniums or what have you, which are older generation CPU architectures where you get more performance at higher clock speeds with things like RK3399 and Raspberry Pi. So one of the reasons they've stuck with the older platforms is because the older platforms still offered a nice, well-rounded approach with the SATA SSDs and reasonable performance. Obviously, ARM-X6 is slightly more dated than a Titanium, being an older product. But I get, a lot of people who've talked to me at the show today have said to me, Andrew, I'm still using my ARM-X6, and then the question then follows, or whatever they want to ask about follows on from that. And so one of the things I'm very conscious of is what can we offer people today that is genuinely all-round better than the ARM-X6 that they've had previously. I'm seeing end on the thing, does that mean I'm...
Well, I'm looking at the clock. I'd like to have one. Someone would be the right as well.
Yeah, okay, so I will wrap up very momentarily. So, I mean, so what was that? Yeah. Complete successors for ARM-X6s that don't leave you thinking, oh, well, it had this feature that I don't have anymore, type thing. So this is one chassis, also available in black, but I thought showing it in a different colour was a little fun and nice. So basically, what we have here, we have 8 USB ports, 2 on the front, 4 on the back down there, and 2 more on the motherboard connection. Twin drive setup, NVMe. In many ways, basically like the Mini Pi, but with more USB connection functionality and a more desktop type performance profile, so it doesn't kind of fall off your desk if your cables are too heavy. Up to 4K, 4 gig RAM, all the usual goodies, and a nice fast rollover system. We do have a couple of chassis that have CD drives in if you're feeling that you can't let go of the CD drive, or you could buy something like this with a USB CD drive plug it in when you need it, stick it in a drawer when you don't, sort of thing, because let's be honest, when did you last use your CD drive? Somebody at the back says yesterday. But you know what I mean. There's also a nice silver one that's sort of about this sort of square and about that thick, that is essentially the same technology, just squashed down if you don't fancy a little tower. But the idea was to give you a few ideas of what the chassis could look like, and then you just pick one you fancy, and we'll build your system in the chassis that you like, or with the features that you want. So these are a little bit more bespoke. The price is $399 to sort of, I suppose if you had everything tricked out to max, you'd probably get to sort of $399 to $499, something like that type price range, depending on what you had. But the idea was to have something in the middle between the Mini Pi and Hydra at the top of the tree, which has up to 6 NVMe ports, depending on how many heads and things you have connected. I've talked about Hydra and other things, so I won't bore you with that. But that has lots of NVMe ports too, so if you have a Hydra, you can automatically get the NVMe support. We also have a load of pre-formatted NVMe devices, adapters and things with us. If you wanted to buy anything like that at the show, if you've already got sort of equipment that can do NVMe, you can buy a drive off us, and obviously get the software for that free of charge if you buy the drive. So what we're doing is, rather than, initially I had planned to charge for the software, but in light of what's happened since, it seems more sensible to sell it with hardware and essentially give away the driver if you buy the hardware from us. Or if you buy a computer from us or other relevant device, you get it free of charge. Finally, just worth mentioning that NVMe is in, the Pinebook Pro has an NVMe slot. We're 99% of the way getting that there. It's just finalising the PCI Express side of things on the Pinebook Pro. But then you will have a laptop with Wi-Fi and NVMe and eMMC and SD card and 1080p and you name it, you get it. Pinebook Pro, pretty cool. So yeah, there's also a new photo desk with WebP graphics support, which you can see on the stand. I was going to fire up this computer, but it's too late. You all want to go to have lunch. Any questions? Really? Okay, you must be all really hungry and just want to get out. So,
I think he's called stone silence.
have fun, everyone. Enjoy Bristol.